Our first coding example is using Java input-output package, writing text to a character stream. In our case, the stream is attached to an output file like this. And always when I'm looking at Java code dealing with files, first question I ask is this strictly a plain text, binary, or random access mode of operation? So the writer class hierarchy is designated for character streams for processing plain text files. And why do we need this? Well, this is just how you can write plain text into a file. You see how we construct the output object from a combination of nested constructors like this, and the writer in this Java I/O package is an abstract class for writing to character streams. PrintWriter prints formatted representations of objects to a text output stream. This class implements all of the print and printline methods we already know in our system.out, which is the standard output stream. The buffered writer, which is shown right here in our diagram, implements a writer abstract class to write text to a character output stream, buffering characters to provide efficient writing of single characters, arrays, and strings. So this is really Java support in this instance for buffered exchange of information with the operating system facilities of writing into a text file. And we're also using FileWriter class, which implements basic support for writing character files. So you can see it also here in our hierarchy. So we're using this part of Java I/O package to deal with plain text file writing. Also, quick note about this Java IO.file. Java NIO file path is more recent than Java file library class. So it does everything that Java IO.file can do. Generally, path class does everything in a better way, so for all new projects we use path class. However, there are millions of lines of Java code using the original Java I/O file. Therefore, we must know about both of these classes since backward compatibility is important. And strictly speaking, the path here is an interface, not a class. That's why we need to call paths get, this method, to create an instance of the path object. And as we begin to see more of file processing examples, oftentimes they may look very similar, like when somebody gives you verbal driving directions such as drive straight, then take a slight right, take a left at the corner, take another left, and so on. So it's difficult because all driving directions are very similar, and any misturn would throw you completely off the track. So I suggest you keep writing your own notes about Java library and store your samples someplace where you can find them when you need them. So also I want to compare this example with a Python and C++ versions that roughly do the same thing compared to Java. So this is a Python example, only 3 lines of code. And you see there are some differences here. Java library designers decided to make file input-output spectacularly object-oriented with bells and whistles, and strictly enforce error checking with this try and catch exception handlers. All memory buffering is also completely exposed by this buffered writer object. The path must be properly processed before the file is opened, and everything must be wrapped inside a class, and so on and so on. So no wonder Python is gaining some popularity every year. C++ maybe not as much, but it also looks a little bit simpler to write a simple text file. Nevertheless, let's move on quickly through the rest of the examples. I'm not going to copy and paste every single one of them, but you should definitely try as many samples as possible on your own computer, just to make sure everything compiles and runs as expected.